In this episode, we're going to learn how to work with parabolas. First, there are three forms for parabolas. Number one, standard form, which looks like this. Number two, vertex form, which looks like this. And number three, factored form, otherwise known as x-intercept form, which looks like this. We will begin by reviewing what standard form tells you about a parabola. We're going to take a look at two different examples of what standard form teaches us about a parabola. Here's the first example. In this parabola, we can see that the a value is located in front of the x squared, which is 2. The b in front of the x is -6, and the c value is also -6. Remember that the a value tells us whether or not the parabola is opening up or down. Since the a value in this parabola is +2, this parabola opens up. Also, the a value indicates whether there is a vertical stretch or compression. In this case, a being 2 indicates that there is a vertical stretch by a factor of 2. The other important thing that standard form tells us is the y-intercept. The y-intercept is always your c value, because if you plug in x equals 0, that will always give you the y-intercept. And in this case, the y-intercept is -6. So the important things you can take away from this parabola in standard form is number one, it opens up. Number two, there's a vertical stretch by a factor of 2. And number 3, there is a y-intercept of -6. In example 2, let's quickly indicate all the important things about this parabola. We will also attempt to graph it using a table of values. First, since a is -2, the negative sign indicates that this parabola is opening down. Second, since a is -2, the 2 indicates that there is a vertical stretch by a factor of 2. Last, we know that our y-intercept is -16 because that is our c value. Now, let's attempt to graph this using a table of values. I'm using a table of values because standard form doesn't tell us anything about the vertex or x-intercepts. It does, however, tell us where the y-intercept is. The y-intercept always occurs when x is 0, and we know when x is 0, the y-intercept here is -16. Now, the only other way that we can come up with extra points on this parabola is by inputting different values for x and solving for their associated y values. First, I will input x equals 1. And after I do the math, I end up with y equals -6. Next, I will input x equals 2, the same way that I plugged in 1. After I figure out all the math, I end up with y equals 0. So, I know that when x is 2, y is 0. Next, I'll do the same for when x is equal to 3. And when I finish all the math here, I end up with y equals 2. So I have the point 3, 2. The last point I'm going to plug in is x equals 4. And if I plug in x equals 4 and do all the math associated with this, I end up with y equals 0. Remember that a parabola is perfectly symmetrical on either side of the vertex. In this case, I know that the vertex is 3, 2, because my y values go from -16, higher up to -6, higher to 0, highest to 2, but then it goes back down to 0. In fact, I can use that vertex and come up with a bigger table of values. We know that on either side of the vertex, the heights repeat themselves. On the left side of the vertex, at x equals 2, we have y equals 0. And you could see at one point to the right of the vertex, when x equals 4, y is also 0. That means When x is equal to 1, we have y equals negative 6. So at x equals 5, y is also negative 6. It is a mirror image on both sides of the vertex. Also, we could extend this because we know when x is 0, y is negative 16. So when x is 6, y is also negative 16. You can see that the most important point to find here would be the vertex, so that you can use the mirror image to come up with different points on either side of the vertex. Now, if we plot this parabola, it would look something like this. And again, this verifies that this parabola opens down and it crosses the y-axis at negative 16, even though it's not in our picture, but it is in our table of values. Now let's take a look at vertex form. In this example, this parabola is in vertex form. Let's list all of the things that we should know about this parabola. Number 1, the a value is positive 1/2. This means that the parabola opens up. Secondly, because a is positive 1/2, this also indicates a vertical compression by a factor of 1/2. The third thing that this parabola tells us is that h is positive 3, which indicates a shift to the right by 3 units. The fourth thing that this parabola tells us is that k is equal to negative 4, which indicates a shift down by 4 units. This is called vertex form because you should be able to look at this equation and tell me what the vertex is immediately. Since this parabola shifted right by 3 and down by 4, the vertex of this parabola is 3, negative 4. We could then easily graph this parabola using a table of values. First, we know that the vertex is 3, negative 4. Next, I will input two x values on the left of this vertex into this equation to figure out the associated y values. When I plug a 2 into the formula, I end up with negative 3.5 or negative 7/2. Next, when I plug a 1 into this formula, I end up with y equals negative 2. Now I can use symmetry to figure out 2 points on the right side of this vertex. When x is 4, that means that y is negative 3.5. And when x is 5, that means y is equal to negative 2. This allows the parabola to be perfectly symmetrical with the same heights on either side of the vertex. Now let's quickly graph this parabola. When you plot all the points, the parabola should look something like this. Notice that the vertex is 3, negative 4. We also can see that it opens up, and also the equation of the axis of symmetry is always x equals h, and in this case, x equals 3. Now let's take a look at reading factored form. It's sometimes referred to as x-intercept form because r is the first x-intercept and s is the second x-intercept. Let's take a look at this example and come up with the most important points about this parabola. First, we see that the a value is positive 1/4. That means that this parabola opens up because it's a positive and that there is a vertical compression by a factor of 1/4. Next, we will find the x-intercepts by setting y equals 0. Now we have 1/4 times the first bracket multiplied by the second bracket is equal to 0. That means either the first bracket is 0 or the second bracket is 0. If the first bracket is equal to 0, then we set x minus 6 equals 0. That means x equals, bring the negative 6 over to the other side, 0 plus 6 is 6. Similarly, the second bracket, x plus 2, if that is equal to 0, then we can solve for x, bringing the 2 to the other side, and x equals negative 2. These are your two x-intercepts of the parabola. Now we can use both x-intercepts to find the vertex of the parabola. First, we can plot both x-intercepts on a Cartesian plane. Next, we can find the middle of this parabola, otherwise known as the equation of the axis of symmetry, by finding the middle between the two x-intercepts. In this case, the middle, or the equation of the axis of symmetry, is x equals 2. Now that we know the location of the vertex, we can simply plug in x equals 2 into the original formula of this parabola to figure out the location of the vertex. After plugging in 2 for x and finishing all the math, I end up with y equals -4. Therefore, the location of the vertex is 2 for x and -4 for y. Now we can draw a continuous curve that connects the vertex with both x-intercepts. And we can see that the parabola opens up. It looks like a vertical compression of a quarter, and the parabola passes through both of the appropriate x-intercepts.